Hi everyone, my name is Tim Hoole and welcome to this demonstration of our secure desktop provisioner. In this video, I'll demonstrate the Secure Thingz desktop prototyping capabilities as part of our complete solution from inception to volume production. I'll follow on from Raphael's in-depth video on using embedded trust with the protection of provisioned data using secure enclaves, specifically NXP PUF technology and their LPC55S family of devices. He demonstrated the Secure Thingz development workflow using IAR's Workbench with the embedded trust tools installed. He created an application, a secure boot manager, set up security context, as well as mastering and setting up a debug session. So let's have a closer look at the components used for desktop provisioning. Firstly, the security appliance. So this is our hardware security module, including a FIPS 140-2 compliant module. It's solely responsible for handling of all of the provisioning security. It has a convenient 4-port hub to attach multiple IJET probes as well. Next, we have the LPC55S69 EVK that we've chosen for this demonstration. This is connected to an IJET probe, providing connectivity to the LPC55 device on the board. And finally, the secure desktop provisioning application running on a Windows host, and this is the main controller of the system. I'd like to briefly recap on the process for exporting a package for production. This will give us some insight into the parameters that are required and their significance in secure provisioning. Firstly, the trusted application package. This selects the mastered application and its associated security settings in the security context. The OEM identity is a signing key used by the HSM to authenticate the package, ensuring that it's not been modified. It's held in a PKCS 12 container, so you also need to provide a passphrase for the signing action. The production system identity is the certificate of the security appliance that we're targeting. Only that HSM is able to decrypt the contents of the exported provisioning package. The production count is an overproduction protection mechanism. This limits the security appliance to a total number of devices that can be provisioned using this exported package. The product name is a useful identifier for the exported package. This is the name that the operator will see when selecting a package for provisioning in the secure desktop provisioner or in volume provisioning, and the output folder is self-explanatory. So here we are in the secure desktop provisioner. In order to add the product that we've just exported from the IR Workbench, we can do that from here. So we'll just go and find that package and add it in. So there's the name and the product name which we entered during the ET export, and this has all been imported correctly. To start production, we first need to define how many devices we'll be provisioning in this run. We'll also need to attach an IJET. So notice when I do that a programming head is detected, and we can go ahead and start production. Here, the security appliance is validating and decrypting the provisioning information contained within the product package. Once that's done, the system will be ready for a device or board to be connected to the IJET. This may take a couple of seconds depending on the size of your images. Once that's done, the system is ready for a board to be connected to the IJET. Note that head 1 is waiting for a device to be inserted. Once I do that, it's ready for programming. When I start the programming, notice the stream of status events that are reported by the head as the security appliance sequences through all of the provisioning steps. Once all the devices in the production run have been programmed, a short summary is displayed indicating if there have been any failures. Our run of 1 has been successful, so let's connect the device's serial port and boot up the images that we've just programmed. Our demo images have low-level logging enabled in the Secure Boot Manager. Using this, we can validate that the SBM is operating with protection of provision data enabled, i.e. that the provision data is encrypted at rest. We can see that here. We also want to verify that the provision data is accessible. A simple way to do this is to perform the device ID test provided by the Getting Started application. This confirms that the provision data is accessible, i.e. it can be successfully decrypted, and that the silicon device ID has been incorporated into the device identity certificate. So let's review what's been demonstrated. I showed how to export a package for production from the IR workbench, including an explanation of the export parameters and their significance for security. Then, using the Secure Desktop Provisioner, we imported the product package. We provisioned the LPC55 S69 EVK board via an iJet probe. Using a serial connection to the board, we interacted with the programmed images to verify the provisioning and that the protection of provision information was actually active. It's also worth noting here that Trust Zone was enabled. This forms an integral part of the protection of provision information on the LPC55 S69, and the SBM was operating in the trusted domain while the Getting Started was in the non-trusted domain. So in closing, I'd just like to say thank you for your attention, and if you have any questions, please do send an email to fae@ir.com. Thank you.